activity on my favorite program, Geometer Sketchpad. Before we get into that, though, a little bit of vocabulary. So far this chapter, we have been talking about finding segment lengths in triangles. Remember, we started with tangents, lots of Pythagorean theorem. And then Monday, we talked about arcs and chords. Still a lot of Pythagorean theorem. We're switching gears now and dealing with finding the measures of angles. Before you can find the measure of an angle, you need to be looking at what arc it's intercepting. If you look at that description of learning at the top of your notes, the first thing that you must know in order to accomplish anything in this lesson is be able to look at the angle and identify the arc that it's intercepting. So I think I have it in your notes earlier than it is on my screen. But one of the things that you'll probably hear me say whenever someone doesn't see the arc that the angle is intercepting is I'll ask you, what's Pac-Man eating? See Pac-Man? See Pac-Man? I'm old, aren't I? You all don't know who Pac-Man is, do you?
Yes, we do.
Yeah, you do? Okay. I was about to get dizzy. All right, so central angles we've talked about before. For example, angle 1 is a central angle. Its vertex is on the center of the circle. We've talked before about how the measure of that central angle is the same as the measure of its intercepted arc. What I want to talk about today is the measure of an inscribed angle, which would be like angle 2 in this diagram. Notice where its vertex is. Its vertex is on the circle, right? So, thinking, yes. Where did my stuff go? Okay, so I've built these circles so that you can go up and click and drag a point and notice the relationship between the angles and the arcs. You all love coming up and playing with my technology. Please play with my technology. Someone? No? Not today? Alyssa, I can always count on you to play with my technology. No? Click and drag a point. Click and drag. Oh, click and drag. Woo, what's the numbers dance? Can I answer? Sure. Okay, so what I'm wanting you to notice as she's clicking and dragging the angles is, or clicking and dragging the points, is the relationship between the angles. So notice that she clicked and dragged point C, and those angles dance. And first of all, property that a lot of you want to kind of spit out very frequently is they're congruent. But, oh, Brianna's shaking her head. No, they are not congruent. Helena? Which angles are you saying will be? Go ahead. Thank you. Opposite angles of a quadrilateral inscribed in a circle, absolutely, will be supplementary. So you see that somewhere in your notes that no matter how we click and drag these angles, notice that those opposite angles of the quadrilateral are supplementary. You see that somewhere in your notes where you can fill in the blank for that property. There's two other things that I'm wanting you to notice up here. Anyone else feeling like clicking and dragging? No? Oh, there you go. Oh, Helena, hit it. Okay, so we already have a property for the one on the right. We haven't talked anything about what's... Okay, C is fixed. Try clicking and dragging the point A or B. All right, well, that didn't change the angle. How about if I click and drag point A? Okay, and that angle is not budging. Why? Why is it a right angle? Okay, so what do you notice? Thank you, Helena. What do you notice that was always the same in this diagram? All right, but what else? Segment AC, for example. What do you notice about segment AC? It's always the diameter of the circle, which means that arc AC is always the same arc. It's always a semicircle. All right, someone else? The last one? No? Mrs. Clouse, you can do that. Alyssa. How about it? Okay, so the central angle, remember we talked about this before, the central angle and the intercepted arc are the same. What's new to us today is these inscribed angles. Any thoughts on how we're going to find inscribed angles from here on out? What do you notice, perhaps, about the inscribed angle, Grace? It's half the intercepted arc, absolutely. So hopefully you've kind of followed along with your notes and seen that the measure of an inscribed angle, as Grace just told us, is half the intercepted arc. And that an angle inscribed in a semicircle is 90 degrees, or a right angle. And then opposite angles of a quadrilateral are, what did we notice? We noticed that they were supplementary. Oh, that was funky. So in problem 1, we're asked for the values of A and B. Please notice the difference. A, ladies, A is the measure of an arc, whereas B is the measure of an inscribed angle. So, arc A. Any thoughts? Where did you get the 108? You would not add those two things together. Be careful. Think about what we realized earlier, that the measure of an inscribed angle is half the measure of its intercepted arc. Okay, so let's talk about all this stuff that we have in here. The A is an arc, the 56 is an arc, the B is an inscribed angle, and the 52 is also an inscribed angle. Okay, so 52 is an inscribed angle. That means it's half of its intercepted arc. What arc is the 52 intercepting? Not just A, be careful. If it helps, once again, tracing, say that again, Alyssa. The A and the 56 put together, absolutely. So, how are we going to use that to find the arc A? Grace, was that your hand? Absolutely, yes. Double the 52. And then do what with it, Grace? Okay, she started us off. Someone want to finish that? Subtract the what? Not from 180. 180 involves a semicircle. I have no guarantees that anything up here is a semicircle. Grace, now you see it. Subtract the 56 from it, yes. A will equal 104 minus 56, giving me 48, thank you. Okay, so realize you're going to be working backwards sometimes. For angle B, we already talked about how angle B is an inscribed angle. So I know it's going to be half of its intercepted arc. What is the intercepted arc for angle B? Say it again, please, Helena. Right. So angle B is half of 56, giving us 28 degrees. So how about if two inscribed angles are intercepting the same arc? What do you think will be true about those angles? They'll be congruent because they're cutting off the same arc. They're half of the same arc. So angles inscribed angles intercepting the same arc are congruent. Problem 2 is talking a little bit more about stuff that we were dealing with before. Half of an inscribed angle. Angle 1 in part A here, that's 90. Angle 2, notice, is intercepting the same arc as the 43. So then angle 2 is 43. Pause for the your turn below. So in that diagram, we have a chord intersecting a tangent. Since that angle is still on the circle, we treat it as if it's an inscribed angle. So the measure of the angle formed by a tangent and a chord is also half the intercepted arc. So in problem 3, angle DBC is that angle formed by a tangent and a chord. It will be half of its intercepted arc. Oh, but darn it, they didn't give me the measure of arc BD. They gave me the measure of arc BED. They told me that that arc on the other side of the angle that I'm trying to find. What do I do? One person. Hey. Okay, start by subtracting this 214 from 360. That gives us 146. What did I just find, Kate? Arc BD. And then what do? Take half of it.